Welcome to Let's Make a Game Platformer, episode 23. In last episode, I have added the first enemy to the game, which is at the moment only patrolling. So by going back and forth on the platform, it is put on in the level definition. However, the only way I was checking there if the enemy actually falls off the platform. However, there's one other case in which the enemy should be turning back, and it is going to be demonstrated in this level that I created, modified actually the existing level, is that whenever the enemy hits the wall, it should also turn back. So this is the first thing I'd like to cover in this episode. And to do that, I have to be able to detect that the character has not moved, even though it probably should have. So what I'll do here is in the physics system, when the character is moved, I will send an event saying that this entity has moved, has processed move. So kinetic entity, and let me create the event. Let's call it entity movement processed. Extends event, and we'll have here very similar events to the fields to the should entity move, except the cancelled one, because we will not be cancelling it. So no cancelled, and constructor, and no cancelled. Okay, so we'll be giving old position, new position, and let whoever wants to act based on those all the data it might need. So entity movement processed, we have old grounded, old location X, old location Y. Kinetic object is grounded, so the new one, new location X, and new location Y. So this is going to be invoked only if the movement was not cancelled. So now in our system, we can now detect if the position has changed, and if they did not, we figure out, okay, for some reason something has blocked the way for the character. So that's how we can process it. However, there's one more situation in which can this happen, and that is if the time since last update, which is in milliseconds, was less than 1, so it was 0. And that is certainly possible in our case, because at the moment our FPS is over 1500, so we get at least 500 frames that are taking 0 milliseconds. So all we have to do is just say that if seconds is greater than 0, then we process everything. Otherwise, we do not. And that also saves us time, because if the seconds is 0, then all the multiplications for the time that is used here for calculating the acceleration to increment the velocity and so on is going to be wasted. We're going to waste processing here if the seconds is 0. So I'll check it here that if it's 0, then we'll not do any processing in this processing physics. And so this situation will no longer be possible, and we'll always have, if something moved or can move, these will be different values. So let me go now to the AI and movement. And the movement system. Yes, so in here, movement processed. Entity movement. Entity and AI apply movement if it does not fall. So I should probably rename this apply movement if possible. And I have to probably check. Is this, I don't remember now, is it a part of the... I don't think it's here. No, it's not. It's added by the... Okay, so let me rename this. Can move possible. Move if possible. So if it has not moved, so if event get new location X equals to new old location X, and event get old location X, event get new location Y. Sorry, this should be Y. And let's make it the same way. So new location, old location, old location. Let me just put it here. Okay, X, X, Y, Y. So if it has not moved, even though we think it should have, that means that we have to notify that it cannot move anymore. So it's probably just hit a wall or some other obstacle. And in case of our AI, that has the, if it cannot move anymore, it flips direction, it will just turn back. So let me check if it works. Yes, it does. Well, I should probably jump better. Okay, so we now have patrolling entity that is correctly patrolling even if it hits the wall or falls off, would fall off the cliff. Okay, so we have this now. Now let me work on actually with what should happen if player character overlaps this enemy. Player should die. That's another expectation. So let's go with this. However, I wouldn't want to just do this for this one case. Player overlaps an enemy. I want to introduce something which is called factions. So we can define multiple factions in the level and specify, okay, this faction is an enemy of this faction. So player faction can be enemy of bugs faction, and there might be a third faction that is friendly with players but enemies of the bugs faction as well, and so on. So you can imagine this being a war, sort of. And to do that, I'll add to the logic. I add a new package here. I'll name it faction. And I'll add two components. Faction components, which will define the faction, what properties of the one specific faction has, and the property it will have is enemies, a list of enemies. Not this list. The Java util one. Okay, and also name, and another component which is gonna be faction member component. And it will specify to which faction this specific entity belongs to. At the moment, we will do that one entity can belong only to one faction. Later on, we might change this, but then if we do this, it's going to get much more complicated. Okay, so what's interesting about it is that we can, of course, first of all, modify the faction members here, but also we can modify who's the enemy. So, for example, you can imagine that player is going to be dying when he approaches the bug. However, if he drinks a potion for the duration of 10 seconds, he might be invulnerable to this specific types of faction of enemies, like bugs, but might not be vulnerable. I might be vulnerable to some other enemies. So this is something that can be changed here. We might modify the enemies, but for now, let's just do a very simple one. So for this, we will have a faction system. We'll register system, and first of all we will inject entity index manager, because I need to create something that will allow me to go through all the factions defined in the level. So life cycle system, and I'll have to create a faction component, faction entities. Okay. And in the level definition, where will it be here? So we have this level. So in the level component, we will have additional objects or entities, and in here, rather than, we don't have them at position, they don't have a specific position, they will be have just we will have just an array of entity names. Oh, sorry, prefab names. So player, faction, and bug faction. Okay, so I'll have to create those prefabs. Factions, player faction prefab, faction component, and in the faction component you have name, player, and we have enemies, if I remember correctly. Enemies, yes, and it's an array of enemies, and it's an array, and we'll say here bugs. Bug or bugs? No, it's a bug faction, not bugs faction. Okay, so we have only one at the moment, but we can later on add more. So the other one is bug faction, prefab, and let me copy this. Name bug and enemies player. Okay, so now in the level entity system, I have to we have to modify the level component still to add the new stuff that I've added. So additional objects. It's not a map, it's an array. Am I correct? Double check that. Yes, it's going to be an array of strings. Additional objects. And in the level entity system, I'll check if level get additional objects is not null. I will ask prefab manager to get the prefab for me, and then I'll ask the entity manager to create entity based on the prefab. Okay, so now we are loading the factions, and so let me now get back to the faction system. Here we want to receive an event, enemy faction overlap, and what's it called? Hitbox overlap event. and we are looking for something that has a faction member component, and event get other entity, and if the other entity has component faction member component, and if other entity, so now we'll get the factions. So faction member get faction name, and other entity get component faction member get faction name other faction. So other faction. So in here we'll add a new method. If our enemies faction and other faction. If they are enemies, we'll fire an event enemies overlap. Okay. Entity ref send new. Okay, let me create here a new event. And it's going to be very similar to hitbox overlap event, where we'll have just other entity. So basically we're just specifying that it's not only just some hitbox and override, but it's specifically enemy overlap. Okay, so new enemy overlap event, and we pass an other entity here. So now I have to implement the our enemies method. So I have to do get enemies for faction, and it will return a list of enemy factions. So I have to go through all the faction entities. I've added the support for iterating over. The index now is iterable, so I don't have to type get entities. Specifically, I can just do a for over it. And faction entity get component faction component class faction if faction get name equals faction. Let's call it faction object here. Okay, maybe I should instead create a method get faction name like this, so that I might be using it later. What happened there? Okay, let me type it quickly again. No, wait. Something weird happened. Get faction name, and I will iterate through the faction entities. Faction entity get component faction component. If faction get name equals faction name, return faction, otherwise return null. And we will not worry about this case where we don't find the faction at the moment, because that means that the level is incorrectly defined. Okay, so get enemies, so we'll do get faction by faction name, get enemies here, and what we'll do here, if enemy factions contains other faction, return true. Otherwise, well, there's the other case. We might consider this a bug if only one side of the faction says that they are enemies of the other and the other does not. But let's just pretend that it's still possible. So we do enemies other faction contains faction. So we can inline this here, and this is OR. Return true, otherwise false. And actually we can simplify it too like this. So these two factions are enemies if either the faction 1 says they are enemy of the other faction, or other faction says they are enemy of faction. Okay, so now we are having this, and we are having enemy overlap. So now in the, let's do a combat package. And let's do combat system. Register system. Profiles, gameplay. I have to do the same thing in the faction system. We don't need it in the menu. So combat system. And we will be receiving event player overlapping enemy. So enemy overlap event. So if an entity that has a player component is overlapping something that's identified as its enemy, then the player should die. So let me check what was the event for the death. That was in the bounds system, and player death. That's what we want to send. Awesome. So player send, entity ref send new player death. Okay, so what's left is just to specify that both bug and player belong to their respective faction, and that is in here. We have bug. We'll say that this one is faction member component. And what was the name of the faction name? Okay, faction name bug. Correct. And then player, the same fashion, belongs to a player faction. Okay, let's see if that works. So we have the bug there, and let's, oh yeah, we died. We have to avoid it. Yes, okay. Yeah, that's it for this episode. Make sure to like it and subscribe to my channel. Leave any comments you wish in the comment section. Maybe some ideas you have for what I'd like to work, what you'd like me to see, what you'd like to see me work on in next episodes. Thanks for watching, and bye.